Good afternoon all. Welcome to this ETSI webinar on the OpenSlice Release 2024 Q4. My name is Nathalie Guinet. I'm working in the ETSI events team, and I'm pleased today to welcome Christos Tranoris, who is the OSL chair from the University of Patras. Hi, Christos.
Hello.
Kostis Transas, also OSL TSC chair and also from the University of Patras.
Hi.
And last, Rafael Direto, who is the OSL TSC member.
So, hello everyone.
Today's webinar is going to last an hour, and you can ask questions by clicking on the Q&A icon on your right-hand side, and we will try to address your question at the end of this webinar. This webinar is also will be available on demand after, so you can share it with your friends and colleagues who haven't been able to join live today. So now I'm handing over to Christos, who will start the giving an overview of this release 2024 Q4. Christos, the floor is yours. Thank you.
Thanks, Natalie. So welcome everybody to this webinar of our latest release, 2024 Q4. It's the name. Just again, a little bit introduction for those that are new to OpenSlice. OpenSlice is an open source operation support system delivering network as a service and follows some emerging standard development organizations like ETSI, TM Forum, GSMA, 3GPP. Since many years, OpenSlice was developed in many European research projects, and since 1.5 years, it's under the umbrella of ETSI. It comes to complement the other future network activities at ETSI, other SDGs like open source Mano, Teraflow, SDN, OpenCAPIF, and prototypes, experimentation, validation of different telco use cases. And of course, since we are open source, we're able to provide early experimentation and feedback to standardization groups and contribute to these standards and try to enable faster time to market. So OpenSlice, what it does is actually takes advantage of the different controllers, enablers that are out there managing different aspects of a network in an end-to-end manner, from devices to transport, to edge, to core networks, until the public internet. And since we have all this exposure of different APIs from the edge to the cloud, we have built and exposed standardized APIs in order customers or third-party application order services that use this end-to-end service. We include an end-to-end service orchestrator that consumes different APIs from different domains, and in the end of the day, delivers to our end users an end-to-end service. Now, if we focus just on release 2024 Q4 with some highlights, of course, my colleagues next will give you much more details. In this release, you will find 5 new features related to not only the deployment of OpenSlice, but also aspects on monitoring, on enhanced Kubernetes management, new APIs on product support. We have more than 20 bug fixes and also 30 enhancements within previous features. Also in this release, we had the idea of providing add-ons, reusable and replicable projects that leverage our OSL architecture. They attach to our service bus and they provide additional functionality, and they have their own life cycle. A couple of them, it's support now for the Sylva project, a well-known Linux Foundation effort, and another project delivering quality on demand provisioning API from the CAMARA family of APIs. Of course, you can read many details. You can find many details in our release white paper which has a brief introduction on all our features of this release and contains links to further read what these new features can do for you, and also find, of course, the source code. And a few words about our SDG OSL. Since you are here, we're constantly looking for new contributors. We expand constantly our community with new members and projects. Our software is developed with flexible licensing, so we follow Apache license 2. It's very easy to include it in your future projects. As I said, everything is migrated under the umbrella of ETSI. We follow very nice DevOps cycles to deploy our software. And you can find there packages and container images to deploy OpenSlice very easily, either in your machine through Docker Compose or even in a Kubernetes cluster for larger deployments. Also, you can find documentation, either if you are an end user or an administrator user, or you would like to manage an OpenSlice installation, or you would like to find further documentation and open source contents in our website. These are current status of members and participants. As you see, we have not only universities and research institutes, we have well-known operators, and we have many, many SMEs that follow and support our ecosystem. Also, last year, we had our first successful Hackfest at ETSI premises, the so-called ETSI SNS for SNS. We had the opportunity to perform hands-on training to our community, to offer demos, and of course, we expect to have a continuation of these very, very nice events that promote our work. And of course, it allows to know our community, identify issues and problems, and evolve better our solutions. It's very easy actually to join OpenSlice if you're not a member yet, or your organization is not a member, or even as an individual you can join. So there is a very, very simple process for either if you're an ETSI member or a non-member. So you can follow different links from our website to learn how it's possible to join, read our terms, and then start contributing. You can learn, of course, more in the link that appears here on osl.etsi.org. Of course, we're quite active in some social media. You can find our latest news not only on our site, of course, in the portal etsi.org, our source code in labs.etsi.org in OSL repository, but also LinkedIn and the X platform. But also we can have a live chat with our community in Slack, where you can find useful information, exchange ideas, tell us your issues, and promote further your work or any other idea that you have while you're using OpenSlice. So that's it from me. Just a brief introduction of what we did this period. I will hand over now to my colleague, Kostis Tranzas, which is the TSC chair, the steering committee chair of SDG OpenSlice.
Okay, thank you, Christo, for the floor. So this presentation will try to dive a bit deeper towards technical updates. And to start with, these are the latest release highlights. So to start with, we have introduced the OpenSlice addons repository, which is a discrete GitLab project. And it tries to include reusable projects that leverage OpenSlice architecture to enable various telco scenarios. So someone, without changing the architecture of OpenSlice, can implement their own scenarios. And we had some examples as for CAMARA and Linux Foundation Sylva proof of concepts that we also will see later in this presentation. We have also extended the Kubernetes support during this release. We have made major enhancements on the custom resource orchestration logic, and we have changed some, let's say, child issues that we have faced during the first release that we supported Kubernetes. Apart from that, we have extended slightly the TM-Forum API support with new APIs, which is the resource activation and some extensions in the product layer APIs. And stemming from the SNS for SNS Hackfest, where we had many simultaneous users, we made some significant changes in some components and severely enhanced their performance and robustness, particularly when they are used simultaneously. Last but not least, we have introduced end-to-end testing pipelines that currently run in nightly, let's say, manner, and also weekly. So to test the sanity of the code every day, whenever something changes in the development, the main branch respectively. The last, let's say, major feature is a new component, which is in experimental version now, which will be enhanced during this release now, which includes a mechanism to integrate monitoring solutions within the service lifecycle. So picking the topics one by one, before actually that, let's start with the architectural progression that led to this release. So as you can see, we have a new microservice attached to the message bus, which is the Metrico component, and severe enhancements have been introduced to the CRITS component, which is responsible for the Kubernetes orchestration, and Awesome, which is the service orchestration of OpenSlice. What we have also done during this release is to have some detailed release notes that follow every internal component version, as you can see. And there is a link that after every release, someone can navigate there, see the internal version of each component and the respective release notes with the links to the appropriate GitLab issues. So starting a bit to dive into the highlights. So the first is, as we've said, OpenSlice addons. So the intention of this repository is to introduce some loose coupled components so that we don't have to change OpenSlice architecture every time that we want to expand to a new telco, let's say, scenario. So it also, the OpenSlice addons follow their own release management, and we introduce addons throughout the release cycle, which is 6 months. So be sure to check this repository for newly introduced addons. And as we've said, they have their own GitLab repository, which is a standalone GitLab project. Some examples of the addons that we have used throughout this release is the Sylva integration, CAMARA support, and an OpenSlice generic controller. We'll see some more details as we go further this presentation. Starting for the first add-on, which is the Linux Foundation Sylva integration, what we've done is to leverage Sylva capability to manage cloud infrastructures. So what we've done is to implement some resource operators that are able to request and manage workloads clusters given from Sylva. So what essentially this integration achieved is to expose Sylva resources and the Sylva framework in general through TM-Forum APIs that OpenSlice support. The aspects that we have covered during this or at this add-on is a common identity and access management through Keycloak. So through the same Keycloak installation, someone can access OpenSlice and Sylva and have the same roles and the respective roles rather, request workload clusters through OpenSlice, then exhibit awareness of the workload clusters resources. So OpenSlice gets to know which resources reside within the workload clusters, and finally deploy resources in these clusters after the awareness is there. There is a thorough demonstration video on how this was achieved, and also there is a reading material in the documentation section. The second add-on that I wouldn't like to exhaust at this presentation, as we will have a discrete presentation later on, is the CAMARA support. In essence, what we've done is expose a service specification or a service blueprint that a user can order. And when this happens, a Kubernetes pod is created, the custom resource is created, which exposes the CAMARA QOD provisioning API to the user. And when the user actually introduces a CAMARA API request, then this is mapped to another service that runs within OpenSlice that controls the respective 5G core, which is a proprietary service offered by the 5G controlling department or the operator. The latest add-on or the latest introduction to this repository is the generic OpenSlice controller. This was inspired by the Kubernetes pattern, which listens for specific events and take actions. And this was our introduction on a development, let's say, tool that enabled the developers to follow the same approach without the need to develop Kubernetes resources. So what this controller does is to connect to the OpenSlice service bus, advertise a specific resource category that is able to manage as a team forum resource specification, and it subscribes to specific service bus queues, as we can see in the screen, for creating, updating, and deleting specific resources. So what an OpenSlice designer can do is to design a service specification around this advertised resource. And when a user orders this specification, then the orchestrator knows that it will use specific queues to communicate with the controller. The controller will receive the respective messages and perform the requested operations. Again, we have a thorough documentation on how to create your own generic controller in the language, the programming language of your preference. The latest component that was introduced is regardless of add-ons. This is a core component of OpenSlice architecture, and it is metrical. So what we have seen is that services and resources in OpenSlice produce a vast amount of data and metrics. What we had up to now is that every, let's say, infrastructure stack had their own monitoring solution, but we didn't have a way to inherit this monitoring data within OpenSlice and use it so to affect running services. So this is what Metrico comes into play to offer. And this integration of external monitoring data can be leveraged through the lifecycle management rules that affect services based on data changes. Again, documentation is offered, and you are encouraged to go through so you can better understand this feature. We have a high-level, let's say, slide here so as to get you into the notion of this feature. So what happens when Metrico is installed within OpenSlice is that a resource specification appears within the OpenSlice catalog, which will be used by the service designer to design the respective service specification, the resource-facing specification and the customer-facing specification. And then the user will input some parameters, some monitoring queries, the data source of the monitoring solution. And when the service will run, the result will be brought back towards the service as a JSON, let's say, property. So what we can do now, as we will have this result within OpenSlice service, is leverage the LCM rules to create closed loops. Another utility, rather, at this release is a way to migrate services and service specification between OpenSlice instances. There is a discrete utilities project that you can use to do that. And as you can see, you can use this project to migrate service specification from one OpenSlice instance to another. Regarding the robustness of the infrastructure, we have introduced two projects. The one project actually offers infrastructure as a code, which builds a Kubernetes cluster on top of the ETSI OSL infrastructure. And we have also introduced a CI/CD project, which performs an end-to-end test, installing OpenSlice and the prerequisites, and also performing a service deployment so as to check that changes in the code will not affect the core functionality of OpenSlice. Now, regarding the robustness enhancements, the majority of them stemmed from the OpenSlice Hackfest back in SNS for SNS. We had around 26 active simultaneous users and orchestrations. And from that, we had created an epic that you can see in the screen with some specific bugs and things to enhance. And we have addressed them all. So we are safe to say that OpenSlice, actually after the Hackfest, became more resistant towards simultaneous usage. You can see what the Hackfest was around at the respective wiki page. And the whole infrastructure for the Hackfest was supported by PNet, which is an OpenSlice participant. Let's say the last slide that I have is not around the feature, but rather a demo, a demonstration that we had in the SNS that leverages OpenSlice architecture so as to provide an end-to-end open source solution for telco cloud operations. So this is an ETSI SDG-based solution, and it incorporates OpenSlice, OSM, and TFS, and it tries to deliver a zero-touch multi-slice 5G deployment around the cloud-to-edge continuum. There is, of course, a detailed video on how this happened, but in essence, what we had is we had OpenSlice instructing TFS through IETF data models and APIs to lay the transport foundations between three domains, the core, the edge, and the corporate. And this not only had routing, but also access control around the domains. Then OpenSlice instructed OSM to deploy a disaggregated 5G system around the core and the edge domain. So we had two UPFs, one in the core and one in the edge domain, and the 5G core system in the core domain. And what we have managed to do at the end of the day is to have this access management between three devices. So we had one device connected to a simulated environment within the core domain that acquired the domain name of internet, so it had access to the public internet. Then we had another device in the edge domain with the domain name of work, which didn't have access to the internet, but rather had access to specific corporate services, an open, let's say, corporate service. And then we had the computer with a VPN access to the corporate domain, which had access both to open and restricted corporate services. That's it for me. And now I will give the floor to Rafael Direito, which is the technical steering committee member that will show some CAMARA, the CAMARA POC and the CAMARA add-on in general.
Okay, so thank you for introducing me, Kostis, and hello everyone. So this is the final presentation of this plenary, and during this presentation, what we will address is one of our newest add-ons, the CAMARA as a service add-on. But before delving into details about this add-on, let's first address the motivation behind the creation of such add-on. So actually, we know that one of the key aspects of 5G networks is their programmability. So in principle, if a developer wishes to create an application or a service that interacts with the 5G network and requests specific operations on the network, this is technically possible by exploring the various APIs that are exposed by the several 5G core components. So these APIs are standardized mainly by 3GPP, and there is an issue with these APIs. And this issue is the fact that these APIs are really complex, and for a developer to interact with these APIs, ideally the developer needs to have some in-depth telecom knowledge. So to address this issue, the CAMARA initiative was created, and right now it lives under the Linux Foundation. And the main goal of this initiative is to design some simplified and developer-centric APIs to aid in the simplification of the interaction between applications and services with complex 5G features. So by relying on CAMARA APIs, the developers won't need as much telecom knowledge the knowledge that they would need to interact with 3GPP APIs. So in the end, CAMARA APIs serve to simplify the interaction with the 5G network. And therefore, here at OpenSlice, we see also some value in providing a friendly way to interact with OpenSlice TMF services through this bundle of APIs. So now let's delve into what a network operator can do today with what we have on OpenSlice. So let's say that an operator wants to make available a service on OpenSlice to provision a network slice or some 5G UE, or even to create some QoS profiles for 5G UE. So this is technically possible in OpenSlice. And to achieve this, the network operator would have to implement a couple of services. Then the services would be mapped to resources, and they would result in the creation of Kubernetes resources, let's say, for instance, custom resources, when the network operator orders the service that he has created. So this way, we can actually make available these types of resources in OpenSlice and make available 5G resources. Either they are network slices, UE, profiles, whatever. But now let's say that the network operator, instead of only wanting to create the resources, only wants to actually also wants to interact with these resources during their life cycle, which means basically the operator wants to perform runtime operations. So once again, this is also technically possible in OpenSlice. So to achieve these runtime operations, what the network operator has to do is to create a new service and then rely on the service characteristics that the service has to actually tweak its behavior and to enforce new operations. So for instance, here in this slide, we have this profile enforcer service. If the operator wanted to enforce a new QoS profiles on 5G UEs, the operator would have to patch the service characteristics of the profile enforcer. These will lead to some values being updated in the Kubernetes resources that were made available when the service was ordered, and then the changes would be applied on the 5G core and on the 5G resources. So now the operator can perform runtime operations on its 5G resources. But what if instead of the operator controlling this profile enforcer service using the service characteristics exposed in OpenSlice and exposed through TMF, what if the operator wishes to have a CAMARA API controlling this service or actually enforcing these QoS profiles? So technically, the operator would have, well, two approaches. The first one would be, of course, to create an entirely new service, a new CAMARA API, and then implement all the business logic of the profile enforcer in this new CAMARA API service. But still, there may be a better approach. Since the operator already has a service that is performing these QoS profile enforcement activities, why not expose the existing and the running service through a CAMARA API? And this is actually what we are addressing with this add-on, and we are addressing in this presentation. So let's revisit the architecture that I just presented before. So here on the right, we have the already existing service that was created by the network operator. And on the left side, we have the OSL generic domain, where we basically showcase and we demonstrate how we can control the profile enforcer service from the operator with a CAMARA API made available as a service by OpenSlice. So as you can see, we can also create a new service, an OSL generic CAMARA API service, and then we can request the service, we can order the service. When we do so, we have to reference the service that we want to control, in this case, the profile enforcer service. And after a while, this service will become available. The service will lead to some Kubernetes resources being activated in the Kubernetes cluster. And one of those Kubernetes resources will expose a CAMARA REST API. So when this API is exposed, the network operator could then do some requests to the CAMARA API to actually invoke some operations. When these requests are received by the CAMARA API, the CAMARA API service will transform the request that it received in some TMF characteristics patch. Okay, so basically the payload that was received through the CAMARA API will result in the update or on the patching of the service characteristics of the profile enforcer service. And then the rest of the workflow is precisely the one that I have described before. But now here, instead of only interacting with the profile enforcer via the updates of the service characteristics, the network operator and other clients can actually come to the CAMARA API here, make a request, and the CAMARA API will transform these requests into TMF service patches, which will result in the runtime operations that we desire, that we aimed to offer. So to achieve this, we need actually to achieve a couple of topics. So the first thing that we have to achieve is that the CAMARA API service, when it is enabled, it must expose a CAMARA API endpoint, let's say a URL. Now, besides this, the CAMARA API service must also have a reference to the already running operator service. In this case, we pass the UUID of the existing service to the CAMARA service when we order it. And based on this unique ID, the CAMARA service must be able to interact with the original network operator service and update its service characteristics in order to enforce the intended runtime operations. Now, how will these two services communicate? Because right now, well, just now I have said that the CAMARA service needs to update the characteristics of the original service from the network operator. So to update these characteristics, we actually rely on the message queue on which OpenSlice relies on. So every time that the CAMARA REST API is invoked, we will transform the request that was received in the REST API, and we will push a message to ActiveMQ's catalog.update.service topic. And this is how we change the characteristics of the original and already running service that was implemented by the network operator. So basically with this, we can enforce the operation. We can request an operation. But how can we be aware of the results of this operation to know if it was successful or if it failed? So once again, we go back to the message queue, and to actually be aware of the operations that are taking place and that their status, the CAMARA service will also subscribe to a different topic, in this case, the event.service.attribute change. And every time that a service is updated, one of the attributes of the service is updated, a message will be sent to this topic. And since the CAMARA service is already subscribing to this topic, the CAMARA service will become aware of the status of the operations that were requested before. So now let's look at this workflow. So basically, this is what we have today, and this first sequence diagram or workflow only relates with the ordering and the deployment of the network operator's original service. So the first step is, of course, to have the client interacting with TMF Web or directly with the TMF APIs and create a service order. Then the client will have to acknowledge the service order, and after a while, the Bridge component will ensure that this network operator service becomes available in the Kubernetes cluster. Okay, and with this workflow, we basically order and deploy the network operator's service. Then we must do the same for the CAMARA service, but with only a small note. Okay, when we order the CAMARA service, we need to reference the operator service that we wish to control. Okay, so besides this, the rest of the workflow is precisely the same. We do a service order, we acknowledge it, and then Bridge will make sure that this CAMARA API service becomes active on Kubernetes. So when this takes place, the CAMARA API service will start by subscribing to the topic event.service.attribute changed. And once again, I want to stress that this is how the CAMARA API will be aware of the operations performed by the network operator service. Okay, and after subscribing to this topic, the CAMARA API will also the CAMARA API service, will also expose a REST API and update its own service characteristics with this URL. Okay, so this is how the clients of the CAMARA API will become aware of where they can find the API. So when the clients have the URL of the CAMARA API that was just deployed, they can start interacting with this REST API. So for instance, they can request a new QoS profile. And when the clients make this request to the CAMARA API, as I said before, the CAMARA API service will transform this request and it will push a service update message to the queue catalog.update service. So this message will be later on consumed by the TMF API components in OpenSlice, which will update the network operator's service characteristics. Based on these updates, the network operator service will perform the operation that was requested, and it will update its own service characteristics with the results of this operation. So when this characteristics update takes place, a message will be sent to the topic event.service.attribute changed, and this message will also be consumed by the CAMARA API service, since it is already subscribing to this topic. So after receiving this message, the CAMARA API service will actually parse the executed operations, and it will offer the information that it collected through its REST API, which means that the clients can now make some GET requests to the CAMARA REST API and be informed of the current status of the operation that they have requested before. So moving on to the implementation of this add-on, the first thing that we had to do was to find a candidate CAMARA API. And to this end, we chose that we would implement the CAMARA Quality on Demand provisioning API. So as you can see, this API only has 4 endpoints and the payloads are quite simple. So once again, I want to stress that this is one of the key advantages of the CAMARA family APIs. They are quite straightforward and easy to use, even if you don't have in-depth telecom knowledge. So some important considerations before we proceed. This add-on actually depends on two services, as I've been explaining. The first service is a custom 5G related service that most of the times can be implemented by a network operator. And the second service is the CAMARA API service, and this is a generic CAMARA API wrapper that is implemented by OpenSlice's team. Actually, we have an implementation in our GitLab repository. Okay. We have actually also addressed how the two services communicate. We have said that they rely on OpenSlice's message queue, but still we have not delved into the information models that these two services should use to communicate. So regarding the CAMARA API service, we have to establish a set of characteristics for this service. Okay, so here you can see the characteristics that we have defined. You can see that the three first characteristics relate with the message broker, and this is how we will provide the URL and the credentials for accessing the message broker to the CAMARA service that we are ordering. We also have to reference the service that we will control through the CAMARA API that we are requesting, and in this case we use its unique ID. And then we also have other characteristics, and from these characteristics, please have a look at the ones that start with CAMARA API. So these characteristics will be filled in after the CAMARA service becomes available, and the CAMARA service exposes a REST API. So when the REST API is exposed, the service will be updated, and here on the CAMARA API.url, you'll be able to see the URL on which you can find the CAMARA API and interact with it. Moving on to the characteristics of the 5G related service. So as I said before, the CAMARA API needs to know the outcomes of the operations that were requested to the original 5G related service. And this is why we need a characteristic in the 5G related service to expose the outcomes of the operations that took place. So here we have this characteristic called results, and this characteristic basically will be filled in every time that the 5G related service performs an operation. It will output the results of this operation to this characteristic, and this is how the CAMARA service will be able to get the operations that were conducted and also their outcomes. But more than this, we also need to actually have a few characteristics for invoking the operations themselves. So actually what we did here was a direct mapping between the payload that the CAMARA REST API is expecting. We mapped all these parameters to TMF characteristics on the 5G related service. Okay, so every time that we make a request to the CAMARA API with this payload, basically the CAMARA service would place the phone number under this characteristic in the 5G related service, and so on. But now I also want to highlight that if your original 5G service only needs 2 or 3 of these characteristics, you may only rely on them. So let's say that I have created a service that only needs an ID for the UE and the profile that I want to enforce on that UE. If this was the case, I could only rely, for instance, on the network access identifier and on the QoS profile service characteristics. So now let's move on to a demonstration. So the first thing that we did in order to achieve this demonstration was actually to create 2 services. One that represents the original service from a network operator. This service is the one here on the right, to which we call UE QoD profile enforcer. And then we have implemented the OSL generic CAMARA QoD provisioning API. So regarding the ordering of the 5G related service, once again, this service mimics a service that was created by a network operator. And as you can see, the service will have two levels of characteristics. The first level are the characteristics that are required for this service's regular operation. And the second level of characteristics are the characteristics that enable its exposure through our CAMARA as a service approach. So you can see here that the characteristics that are required for the service operations are, for instance, a list of the profiles that are available, and also the downlink and uplink of the default QoS profile that will be applied to all UEs. Now, under the second level, once again, we have done a direct mapping, but I have to stress once more that this really depends on the 5G service that you are working with. So if your service only requires the network access identifier and the QoS profile, you might only have these two characteristics, and of course, a characteristic to expose the results. So now a brief demo on the ordering of the 5G related service. I will move a bit faster than this. So basically, when we order this service, and as I said before, this service will result in some custom resources created on top of a Kubernetes cluster. And this is precisely what we will see now. So as you can see, here is the custom resource that we have created, and it has all the characteristics that we have defined. And actually, more than that, after the service is running, we will also see these characteristics that are used for the CAMARA interaction. So now a brief demo of the independent operation of this service. So until now, we are not relying on any CAMARA API. We are just showcasing how this service works. So we have done a new service order. So if I can move a bit faster. Okay, and now what we will showcase, actually now the UEs have the default profile, but what I want to showcase is that if we update the service characteristics of this 5G related service, this update will result in the enforcement of a new QoS profile, in this case the QoS profile low. So after a while, if we conduct a speed test on the 5G UE, we will be able to see that indeed the QoS of this UE was changed. Moving on to the CAMARA as a service QoD provisioning API. As I said before, when we order the service, we have to pass some information regarding the message broker. This will allow the interaction between the network operator service and the CAMARA one, and we also have to reference the service that will be controlled through this API. So once again, we have created a service order, we have acknowledged it, and now let me just move a bit further. Okay, and here you can see that this service became available. It has here some information about the message broker, and once the service started to run, basically it exposes the URL of where the CAMARA API was deployed, and this information will actually be also on the web UI of OpenSlice, which is what we are seeing now here. And from here, the clients can come and can access the QoD provisioning API, which we are showcasing now. So just another video. This is one of the last ones. So here, our client is using the REST API that was exposed, is making a request to enforce the QoS high profile on the UE described here. And as you can see, when the request is received by the CAMARA REST API, it will update the characteristics of the original service that was made available by the network operator, which is what we are seeing now. So after a while, the original service will actually perform the operations that were requested, and when these operations are actually conducted and finalized, the results of these operations will be exposed through the CAMARA results property. So this is what will happen now. The results have been exposed. The CAMARA API just received the message with this update, and now it parsed the message. And now, if we try to get the status of this operation from the CAMARA REST API, we will see that the status is available. So with this, I finished my presentation. So now we will have some minutes for questions. But before delving into questions, I think I should pass the ball to Christos. I don't know if you have any final remarks that you want to do.
Let's meet all together. Back, everyone. Any final remark?
From our side, thank you, Rafael, for the nice demo. Let's move to some questions from the audience.
So we have a few questions to go through. Could you please mention how this can be used in conjunction with 5G Core? What is the novelty of this solution? And the person says, I'm new to OpenSlice.
Okay, let me answer this question, and if I can take the liberty to answer, try to merge the question coming from the person. So apart from the conjunction with the 5G core, the other question was, what is the difference with the network management system that is integrated within a 5G core? And if the 5G core has to be deployed using Kubernetes? So in essence, to start with this, the 5G core and OpenSlice is not the same thing. So OpenSlice is an operation support system, and its work is to use controllers, cloud controllers, or the network management system itself to orchestrate the 5G core and control it. So what we do is we need a packaging format of the 5G core, which can be either in NAV that OSM supports, or Helm chart the Kubernetes supports. And we have inherent controllers within OpenSlice that we can orchestrate the systems and offer them as a service. So essentially, what OpenSlice does is stitching together controllers and offer composite services. So a service can be orchestrate a 5G core as a service, then orchestrate the transport layer, orchestrate a VPN as a service on top of it, and then, for example, offer user applications. We come to a conclusion that the network management system that comes integrated with the 5G core can be leveraged as a controller within OpenSlice so as to make the edits that there were suggested towards the core. And last but not least, regarding the deployment that involves around Kubernetes, no, the core doesn't have to be deployed in a Kubernetes cluster. It can be deployed through NAV packaging, through OSM. It can also be deployed as Helm chart within Kubernetes. Or for the demo, for the CAMARA that we've seen lately, it can be pre-deployed, and only a network management system can be there so as to offer a passage towards the core. So this, I tried to wrap all the questions.
Thank you. Okay. We have to be quick, try to get as many questions as possible. So how can someone use the OpenSlice add-on repository effectively?
Okay, I can answer this question as well, actually, because it is a wrap on my presentation. So this repository comes in its own lifecycle, apart from the release lifecycle of OpenSlice. So you can have your OpenSlice instance and leverage the add-ons as different projects that when you install them within the OpenSlice instance, your OpenSlice instance, you can execute specific scenarios. and you don't have to update the whole stack, or you don't have to leverage and make updates and new code, let's say, improvements, so as to support new scenarios. And what is more interesting around the add-ons is that a developer can write its own controller or its own add-on. So with your logic, business logic, you can integrate your controller within OpenSlice message bus.
Okay. What was the main motive behind the introduction of the new metrical component?
Okay, let me take this last question, because again, this was in my presentation as well. So the metric component, to wrap up, is a component that brings external monitoring systems within OpenSlice service lifecycle. So with this, we managed to achieve closed loop management. So we orchestrate services, we monitor specific things changed, and then based on our rule design, lifecycle management rule design, we can get the responses from these changes and respectively change the service that these changes actually are allocated to.
I have, I think it's going to be a quick one for Rafael, probably. Which 5G core are you using in this demo? Is it open source?
Well, actually, for this demonstration, we have relied on the Huawei commercial 5G core. But actually, this demonstration could have been achieved using an open source core or even an industrial core. So in our case, to interact with our 5G core, we have the original network operator service interacting with some APIs that we have exposed on our Huawei core. So if you have an open source core, you can do the same. If you have an industrial one, you can do the same. And if you have an open source one deployed on top of Kubernetes, you can even deploy some resources through Kubernetes, and these resources belong to the 5G core. So we have various opportunities here. We have various approaches that we can use.
Okay. I'm reading fast because there's quite a few questions. What is the difference between OSM and OpenSlice? Can't OSM orchestrate the 5G core?
Okay. I was trying actually to type the answer.
Oh, we don't hear you anymore. Do you mute?
I wasn't able to unclick the mute button for some reason. Okay, so I was trying to type it. So OpenSlice is an operation support system, and OSM is an NFV orchestrator. So what I'm trying to say here is that operation support system sits on top of NFVO and other orchestrators. So it can use them to composite services. So what OpenSlice can do is leverage OSM's northbound interface so as to orchestrate a core that is packaged with NFV-based packaging. So OSM will orchestrate the core, not OpenSlice. OpenSlice will instruct OSM to orchestrate the core, or it can orchestrate the core directly using Kubernetes custom resources, which is another, let's say, a way of orchestrating apart from OSM. But what it really does, and I mean, this is the major difference, is that it can join all these orchestrations in a specific orchestration logic. So first orchestrate the core, then let's say execute an HTTP call towards a radio controller, then orchestrate the transport, then deploy an application, for example.
Okay, you have less 50 seconds to explain what's upcoming in the next release, and then we close. Last one.
Okay, sneak peek towards the next release is that we want to make Metrico a bit more robust. So it comes from an experimental feature. We want to make it a stabler one. And also we are introducing quite many changes in the graphical interface and the UI, which is a bit outdated. So we want to give it I lift up.
Okay, so I think we have to close now. Thank you to all for this work and this good presentation. Thank you to our audience. So this webinar is available on demand will be available in a few minutes. And watch out for upcoming webinars on the webinar section of the ETSI website. And I say goodbye for today. Thank you, everyone. Bye-bye.